Hello, this is Mr. G, and this is going to be a practice type question related to the periodic 2 coming up this week on projectiles, right? So, you should definitely be able to do the following types of problems. Let's see, let's toss something here off of a building, of course. All right. So yeah, if something is launched horizontally, right, horizontal, that means the angle at which it is thrown is 0 degrees. Okay, for example, let's say this building is, I don't know, 45 meters high. And you're going to toss something off the building, and then it ends up landing, bloop, over here, I don't know, maybe 12 meters away from the base of the building. And the question is, what is the initial velocity of the projectile here? Is V naught. So, first, I'm going to write down everything I know. Right? And I need a coordinate system. All right, so for this problem, everything is happening in the downward direction. The displacement of this object ends up being below where it started. Its acceleration is directed downward. So for this problem, I'm just going to call down negative. So in that case, we know the angle it's thrown is 0 degrees. I know that its displacement is 45 meters. That's delta y. I know the horizontal displacement is 12 meters. That's delta x. And I'm looking for V naught. So, I think the first thing we should find here is t, right? Because I know that in projectile motion, the horizontal distance is initial velocity. It's the horizontal component of that, which is V naught cosine theta times t. In this problem, theta is 0 degrees, and cosine of 0 is 1. So delta x is V naught times t. So yeah, I could definitely solve this equation for V naught. It's delta x over t. But I still need to find t. So that means I need to consider what's happening vertically, okay? Keep in mind that if something is launched horizontally, the distance that it falls in a certain time is exactly the same as if you just drop it, right? You just drop it, okay? I think we've dropped enough stuff from 45 meters above the ground. Even Sugar Bear knows the answer to this one, right? Shug, what do you think? 3? That's right, it's 3 seconds. 3. But in case you're not sure about that, let's see. Yeah, we do have equations. Although most of these you can answer without using these equations if you just understand the fundamental ideas here. So yeah, we've got something that says delta y is equal to V naught sine theta times t. On your worksheet, this is minus 1/2 gt squared. That's because on the equations we're using, for all of those guys, the default direction downward is negative. In this case, we just let it be positive. Again, the magnitude of the answer is the same either way, right? So again, something else here. The angle is 0 degrees. Sine of 0 degrees, that happens to be 0. And that means this whole term goes away. All right? So including the t here. All right, so then solve for t. Right? So multiply both sides by 2. Divide both sides by g. And then take the square root. Okay, and again, if down is negative, both delta y and this g are negative, and those two negatives cancel each other out to leave everything under the radical sign as positive. So that's going to be, let's see, 2 times 45 meters divided by 10 meters per second squared. So 2 times 45 is 90 meters divided by 10 meters per second squared. Numerically, 90 divided by 10 is 9, and the square root of 9 is 3. Meters, okay, and the meters down here, that gives you meters squared over, I'm sorry, the meters can actually cancel each other out. So 1 over 1 over seconds squared is seconds squared, and the square root of seconds squared, thankfully, is seconds. Yeah, so it's going to take 3 seconds to hit the ground. All the while it's moving sideways. So then, again, now that we know t, we can figure out v naught. So v naught is this horizontal distance over time, so that's 12 meters, divided by 3 seconds. And 12 over 3 is 4, and the units are meters per second. So there you go. Problem done. All right, the next type of problem you should be able to do here is, well, variations on this, right? So let's see, let's do this one. Yeah, more buildings. This is just a variation on the theme here. Let's say now we know the velocity with which it is thrown, and we know the angle is 0 degrees if it's horizontally tossed. Well, let's say that v naught is 5 meters per second. Okay, and it lands right over here. Bloop. 20 meters away. And you guess it, we want to know how high is this, was it thrown from? So once again, in this problem, let me just call down the positive direction. So what do we know? Well, I know that v naught is 5 meters per second. I know the angle at which it is thrown is 0 degrees. I know the horizontal displacement is 20 meters. That's delta x. And here I'm looking for y. So check it out. I have enough information here to figure out time. Okay, yep, I can figure out how long it takes, how long is it in the air, because I know it's horizontal velocity, and I know it traveled 20 meters horizontally. So for those of you that love these equations, it is delta x is v naught cosine theta times t. Right, so then delta x is, well, theta is 0 degrees. Cosine of 0 is 1. So that's just v naught times t. And so then I can figure out t, right? So then t is delta x over v naught. (20 meters) divided by 5 meters per second. That is 4 seconds. Now, I know that a lot of you can just look at these two numbers and immediately tell me, oh, it's 4 seconds. But if you need to look at the expressions as to why that's 4, you've got them. So now that I know that time is 4 seconds, let's look at what's happening in the y direction. So basically it's asking you how far does something fall if you release it from rest and it's falling for 4 seconds. But let's go ahead and look at this thing in terms of these equations. So delta y is v naught sine theta times t minus 1/2 g t squared. Sine of 0 is 0, and 0 times anything is 0. So that whole first term goes away. So delta y is equal to minus 1/2 times 10 meters per second squared times 4 seconds squared. Right, so, and the minus sign, again, this equation here is with the understanding that down is the negative direction. It can be negative, it can be positive, so the fact that we end up with a negative displacement is fine. So minus a half of 10 is minus 5 meters per second. Times, well, 4 squared is 16. Okay, this is actually seconds per squared, and this is 416 seconds squared. So the seconds squared cancel out, and I'm left with meters, so that's minus 80 meters. It lands 80 meters below the initial point that you threw it. Okay. Then, so problems, varieties like the ones we just did here, and then the other types of problems. All right, so let's do one of those. So there's the ground. We're going to throw something here. Let's say that V naught is 10 meters per second. And let's say that this angle, theta, is, who knows, 30 degrees. All right, so we want to know everything there is to know about this thing. We know it's going to go up in the air, bloop, and then land somewhere over here. So we know that. Let's write down, we know that V naught is 10 meters per second. It's in free fall, so its acceleration is about minus 10 meters per second squared. And that seems to be all that we know. Oh my, so then the questions are going to be, so for example, at its highest position right here, what is its acceleration? Well, it's 10 meters per second squared, downward, because it's in free fall. And all objects in free fall have the same acceleration. Or negative 10 meters per second squared. Then what about how fast is it moving here? What is its speed? At the very highest position. Well, at the highest position, it's just moving sideways. Right? And that sideways speed, that's constant. That's the same as the sideways speed it had when you threw it initially. And that speed, that Vx, that is just V naught cosine theta. So that is 10 meters per second times cosine 30. Cosine of 30 is about 0.86. And so 10 times 0.86 is about 8.6 meters per second. 8.7, 8.6. That sideways velocity is the same everywhere along this path. So at the very highest position, it's no longer moving up or down, it's going sideways. So yeah, so your velocity at that position is 8.7 meters per second. What else? How long will it take to get to this highest position? How long will it take to reach that upward position? A bunch of different ways of figuring this out. One way is to look at what's happening, well, vertically, of course. Let me redraw this on the next page. Actually, let me just erase a bunch of this stuff here. So vertically, the motion is exactly the same as if I just tossed it straight up with an initial velocity equal to the vertical component of this 10 meters per second. All right, so this V naught in the y direction is what we're looking for now. So that's going to be V naught. That vertical component is equal to V naught sine theta. So The V naught is 10 meters per second. The theta is 30 degrees. Sine of 30 is 1/2. 10 times a half is 5. So the vertical motion is just something tossed straight up at 5 meters per second. How long will it take if you toss something straight up in the air? It stops up here. Well, if it's losing 10 meters per second, it's going to take 1/2 second to get up to that highest position. All right. Or, if you want to use equations of motion, yeah, we can definitely do that. For example, what about this one? What about Vy is equal to V naught sine theta minus G times T? We can do that. I know that at the very highest position, Vy is 0. It's not moving up anymore. Now solve for T. So let's move the GT over to the other side, making that thing positive. GT is V naught sine theta. That means that the time is V naught sine theta over G. So 10 meters per second times sine of 30 divided by 10 meters per second squared. Okay, sine of 30 is 1/2, as we already said. 10 divided by 10 is 1. The units come out to be seconds. So yeah, the time it takes going up is 1/2 second. There you go. Okay. What about this? What about how high does it go? What's the maximum height? So, all this stuff again. Yeah, again, there are a bunch of ways we could figure out what its maximum height is. How about we could use, that delta y is v average times t. All right, so the average velocity. So here, again, this is looking at the vertical component. So it starts off with an initial velocity in the y direction of 5 meters per second, right? Because it's 10 sine 30, and then at the very highest position, it stops moving. So that means that its final velocity up here is 0. What is the average of 0 and 5? It's 2.5 meters per second times 1/2 second. So that gives you a that gives you a distance of 1.25 meters. That's how high it goes. That's the highest position, and that occurs during the midpoint of its flight. And one more problem here, right? Let's do this. So let's launch something again. Say that V naught is 100 meters per second. And the angle at which we launch it is 60 degrees. And so what I want to know is how fast is it moving? In 1 second after I throw it. Okay, what is its speed after 1 second? All right, so it's all about these little vectors. So So after 1 second, it's still going to be moving sideways. That's Vx. And possibly maybe it's still moving up. That's Vy. And the speed is the Pythagorean theorem business where you take these two sides, you square them, you add them, and take the square root. And the diagonal is V, right? Or the speed or the magnitude. All right, so that's going to be, let's see, well, the Vx part is V naught cosine theta. So that's 100 meters per second times cosine of 60. Cosine of 60 is 1/2. 100 times a half is 50. So its sideways velocity is 50 meters per second. Right? And that's that sideways velocity for the entire duration of this trip here. So then Vy, that speed's changing. It's losing 10 meters per second every second it's in the air. Right. So the initial Vy is V naught sine theta. That is 100 meters per second times sine of 60. Sine of 60 is 0.866, about 0.87. So 100 times 0.87 is 87. So that's its initial vertical velocity. But the deal is it's losing 10 meters per second vertically every second. So if you start off with 87 and you lose 10 meters per second, what's your speed? Yes, it is 77 meters per second. For those of you that like the equations, yep, we definitely have an equation for that. That equation is, anyways, let's do this thing here first, though. This is going to be, and I'm not going to go through all the math here, the square root of 50 squared, that is 50 meters per second squared, plus 77 meters per second squared. Sorry, meters per second. The whole thing is squared. Yeah, so square those two guys, add them, and take the square root. The other way to get this vertical velocity after 1 second is as follows. Vy is equal to V naught sine theta minus g times t, which is exactly what we just did with words without writing down all these confusing equations. They can be confusing. So this is going to be 100 meters per second times sine 60 minus, the g is 10 meters per second times 1 second. So this is doing what we just did, right, in like plain English here. 100 times sine of 60 gives you that 87 meters per second, and you subtracted 10 times 1, because it's losing 10 meters per second for 1 second. So there you go. Problem done. Okay then, that's it for this little review session. Thank you very much.